I built this 8x8 image storage device that can save and load images and build a boat for treasure. Want to see how it works? Stay until the end, where I'll show the finished build in action. There are 3 core components that make this possible: a T flip-flop, a 6-bit color system, and a 6-bit memory latch. Every single pixel contains 6 T flip-flops, 1 6-bit color system, and 1 6-bit memory latch. Once we build those 3 parts, we can combine them into one complete pixel, then repeat it 64 times to create the full 8x8 display. Let's start with the most important component, the 6-bit data latch, or D latch. First, we'll build a single D latch. Here's how it works. Whenever the store input is activated, the latch copies the value currently on its data input and remembers it until the next time it's updated. To make a 6-bit D latch, simply place 6 of these latches side by side and connect all of their store inputs together. Now all 6 bits are stored at the same time. Next, we'll build the 6-bit color system. For this to work correctly, you'll need 6 distinct but similar colors. I found that using lighter and darker versions of 3 base colors gives the best range while still making each bit easy to distinguish. Here are the RGB values I used: dark blue 67 133, dark green 33 79 17, dark red 100 133, light blue 67 100 67, light green 30 78 35, light red 100 100 67. The final component is the resettable T flip-flop. Pause the video here if you'd like to copy the gate layout. Once you've finished, watch closely as I connect everything together. The brown logic gate is the reset input. Sending a signal to it forces the flip-flop back to its default state, off. The blue logic gate is the toggle input. Every pulse switches the output from off to on or from on to off. The red logic gate shows the current state. Red means the bit is off. Green means it's on. If your circuit doesn't work, one common mistake is the 2 gates on the far end being connected to the wrong outputs. If that happens, simply swap those 2 connections and it should start working. Now it's time to combine everything into one complete pixel. This module contains 6 T flip-flops, 1 6-bit color system, 1 6-bit memory latch, and the display blocks. Right after the memory latch, I've added 6 AND gates. These are important because they let a single lever choose whether you're routing the live inputs or the stored data, which makes saving and loading much simpler. Over on the left are 3 extra logic gates. They're only there to make wiring cleaner. They don't change how the circuit functions. And over here are the save, load, and clear inputs. Now watch as I wire everything together into one fully functional pixel with built-in storage. One quick tip: before trying to load an image, don't forget to actually connect your load lever, unlike I did. Once you've finished one pixel, the hard part is over. Now just clone it 64 times, wire the pixels together, and somehow convince yourself this was easier than drawing by hand. For testing, I'll create a random image and save it into memory. As you can see, saving takes a little while. The game has to process hundreds of logic operations across the entire display before everything settles. And there it is. It works. Here's one final walkthrough so you can appreciate just how massive this thing really is. The finished build comes in at over 9,600 blocks, containing hundreds of logic gates and enough wiring to make troubleshooting interesting.